Up until now, we've only ever measured angles using degrees. So, for example, an angle might be 90 degrees or 180 degrees or 250 degrees. In this video, we're going to talk about a new way to measure angles, which are called radians. They're called radians. It sounds kind of like the word radius, and that's because it has to do with that. It's based on the radius. If you have a circle and you know the radius of the circle and you know the arc length of the circle, so that right there, what that distance around is, the ratio of those two will give you that measure in something we call radians. So radians are really just the arc length, this right here, that distance, divided by the radius. It's the ratio of these two things. And that gives you the measure of the angle in radians. This is just another way to describe, I guess, how big an angle is. We can either use degrees or we can use this thing called radians. We saw this in our calculators when we were doing like sine, cosine, and tangent. We had to make sure that our calculators were set to degrees, because sometimes we would find that they would be set to radians, but we weren't using that yet. Now we're going to start talking about radians. So, radians are pretty straightforward. If you have the arc length and you have the radius, you just find the ratio of the two. So if I wanted to find the angle measure, the central angle of a circle that had a radius of 2 inches, so a radius of 2 inches, and an arc length of 3 pi. So whatever that is, it's going to be 3 pi. What I can do is I can take the arc length and divide it by the radius, and that's how many radians I have. I can leave it like that, or I could write it as 1.5 pi, because 3 over 2 equals 1.5 pi. Okay? I could also take pi, 3.14, and times it 1.5 and just get a plain number. There's several different ways that you can write radians. If I wanted to know degrees, what I would have to do is I would have to use that formula for arc length, the one that's like the length of an arc equals the central angle over 360 times 2 pi r, that same formula that we've been using, and plug in the arc length and plug in the radius, because those are the two things I know, and then I can find what this angle is in degrees. So I would say I have 3 pi is the arc length equals, I don't know the central angle yet, times 2 pi, and the radius is 2. So, I will divide both sides by 4 pi, because 2 times 2 is 4, so that all goes away and the pi's cancel out. So I have 3/4 equals theta over 360 times both sides by 360. That cancels out. And then I learned that if you take 360 and you times it by 3/4 or 0.75, you get 270 degrees. So that gives me a comparison. 1.5 pi radians, or 3 pi over 2 radians, is equivalent to 270 degrees. Let's look at another one. If I wanted to find the the central angle of a situation where we have a radius of 5 and an arc length of 5 pi, I would just do 5 pi over 5, which the 5s would cancel out, and they would just reduce to pi. So you'd have pi radians. Okay, so that was the first one, which compared to 270. Here we have pi radians. Let's see what pi radians compares to in degrees. we would have, so we take the same formula right here. Okay, and we plug in everything we know. So we would have 5 pi is our arc length equals theta over 360 times 2 pi r, radius, which is 5. So if we divide both sides by 10 pi, we get 5/10 is 1/2. Oh, sorry, the pi's cancel out. Equals theta over 360 times both sides by 360. And 1/2 of 360 is 180. So now we know that if you have pi radians, that's the same as 180 degrees when you're talking about an angle. So when you see an angle that's 180 degrees, you could also say that that angle is a measure of pi radians, 3.14 radians. Okay, let's look at this last one. In this situation, we have a radius of 6, and there's an arc length of 12. Let me move all this up here real quick. Okay. So if I want to find the measure this angle in radians, I just do 12 pi divided by 6. 12 divided by 6 reduces to 2, so it's 2 pi. Okay, so you have a measure of 2 pi radians. Let's see what that would be equivalent to if we were talking about degrees. So if we're talking about degrees, I'm going to plug in these two pieces of information into my formula for degrees. So 12 pi equals, I don't know yet, theta over 60 times 2 pi times 6. Okay. You divide that side by 12 pi and that side by 12 pi. That all cancels out. So you have 1, because 12 over 12 is 1, and the pi's cancel out also. So 1 equals theta over 360 times both sides by 360. And you get that theta equals 360 degrees. So that tells us that if you have a measurement of 2 pi radians, if an angle is 2 pi radians, that's the same as a 360 degree angle, which means 2 pi is like all the way around the circle. It's a complete circle, just like 360 degrees is a complete circle. So is 2 pi radians. Okay, now let's look to see how this compares with two different circles that are the same ratios but different sizes. Let's see what that tells us about these two angles in the middle. So if I want to find each of these in radians, I would do 6 pi over 8, and that gives me, reduces to 3 pi over 4, or I could call that 0.75 pi. Okay? So I know that pi is 180 degrees, so 0.75 pi would be slightly less than that. Let's see what that is in degrees. So if we look over here in degrees, we would use our arc length formula and plug in everything we know, just like we did up above. So we have 6 pi equals, we don't know yet, over 360 times 2 pi 8. Okay, so we divide both sides by 16 pi. The pi's cancel out. We end up with 6 divided by 16 is 0.375 equals pi over 360, because that all cancels out also. So I'm going to multiply both sides by 360. And I get 360 times 0.375 is 135 degrees. Okay, so up here we learned that a pi is equal to 180 degrees. 0.75 pi is equal to 135 degrees. Now let's look at this same circle. Notice that the ratio is the same. The arc length is 3 pi. The radius is 4. So that just gives us the same thing we got up there. 3 pi over 4 or 0.75 pi. So if it's the same in radians, we know it's also going to be the same in degrees because there's a 1-to-1 correlation between a radian measure and a degree measure. So we don't even have to do any work over here. We just know that it's also going to be 135 degrees. And that makes sense because these two circles have the same ratio of arc length to radius and arc length to radius, which means this angle in here is going to be the same measure. It just goes out farther in the bigger circle. So that is a little introduction to what radians are, where they come from. They're always the ratio of arc length to radius. So if you have the arc length, you have the radius. You can easily find the measure of the angle in radians just by finding that ratio. It's a little bit more work in degrees, and that is one reason why radians are so nice. Go ahead and try the practice and see how you do. You can always email me with questions, or I will see you on our Google Meet. Bye.